am now going to begin talking about something related to electric fields that once we continue discussion with it, you'll see it's connected with circuits and it'll tie how these charges are related to different things we've been talking about, like voltage. And that's actually the next thing I'm going to talk about. It's called potential, which is measured in volts. It is a voltage, and it is associated with a single charge, believe it or not, in space. So I'm going to draw the charge, and I'm going to draw the electric field lines. I'm going to start off with hopefully a conceptual appreciation of what's going on. So if you have a positive charge of some value here, that's all, just some value. I'm not going to worry about the actual numbers yet. I'm going to draw electric field lines to represent the fact that the electric field lines are directed radially away from the charge. This is called the radial direction. It's just directly away from the charge in any given direction. That's going to be the direction of the electric field. Okay, so I'm going to ask you now to try to imagine this in a three-dimensional framework, but also in a different context. Imagine that every time you have a positive charge, it's kind of like having a mountain. All right, it's kind of like having a mountain. And then the direction of these black arrows is the direction of the force an object would experience if it were placed on top of the mountain, maybe slightly in the north direction for this one, slightly in the south direction for this one. It's going to want to accelerate down the mountain in that direction. So it's kind of like there's a slope on the mountain, and you might think this mountain more as a volcano or kind of a cone. That's maybe a good way to think about it. And whatever side of the cone you put some object is the direction it's going to roll down, or at least experience a force. If you just placed it there, it would roll down that direction and accelerate as it continued to roll down. Actually, it can be dangerous if a mountain, it's called an avalanche, if enough of those happen, and they can get moving quite quickly because they're accelerating. It's kind of like they're falling. But they'll go in that direction because of the slope of the mountain. All right, so that's another way to think about electric field lines, and what they represent would be the direction of a positive charge kind of rolling down the mountain. Because there's a positive charge here, and another positive charge is going to want to get away from it. It's kind of like rolling down the mountain, in a sense. At least to some extent it is. Okay, and now what I'm going to draw is, it's kind of like when you look on a map, and I'll call it a contour map, and hopefully you've seen those before in other classes or somewhere else, where at a given distance away from the peak of a mountain is a ridge, like a ridge line, where it's all the same height, wherever that line is drawn. And that's what these blue lines represent. They're like contours, in a sense, of different height associated with a mountain or a hilltop or something like that. But they're also relevant for the concept of electric charges and what we've been talking about so far. These are lines that I'll say are lines of constant electrical potential, or we just usually call it potential rather than electrical potential because we know it's electrical potential. But it's kind of like different heights associated with a charge as it's rolling down the hill. So the greatest potential is going to be at the one closest to the central charge. And as you get further away, for instance, this one or this one, the value of the potential or the voltage gets smaller and smaller. So potential is kind of like the height or the potential energy. You could think about that in a mechanical sense too. But it's the electrical height. And when you're close to a really positive charge, you're at a really big height. And you're going to fall down if you're another positive charge, and you're released at that point of being close to this other positive charge, you're going to slide down the potential, or slide down the slope here. And you're going to encounter lines of lower and lower potential. Now again, these lines are fictitious. You can have an infinite number of lines in here, just depending on how many you want to represent, but I just chose to represent a few of them. Otherwise, we'd be overwhelmed with these blue lines, and I didn't want to do that. So I just happened to pick some blue lines that represent some constant potential. So they are lines where the potential will not change. It's kind of like a ridge on a mountain if you're on a hike. If you're going around the top of a mountain, You stay at a certain height. That's kind of like staying at that same potential. All right? Now, I'm going to give you a little bit of math here so we can actually calculate what these values of potential are. The units I'm going to tell you right now are going to be the units of volts, and you'll see where that comes from. But it's the same volts that you have on your battery that we've been talking about earlier in the semester when we had circuits, and that we'll continue to see in some of the remaining labs also. So potential, the definition of potential, the symbol for potential, by the way, is V. So that's the symbol for it.